Let's solve this trigonometric equation. 2 sine theta minus 1 is equal to cosecant theta. And we're asked to find all the solutions in the interval from 0 degrees to 360 degrees. So step number 1, notice there's a sine theta and a cos theta. We'd really like this whole equation to be in terms of just one trig function. So let's remember the reciprocal identities. Cosine theta is cosecant theta is the same thing as 1 over sine theta. So rewrite the equation as follows. 2 sine theta minus 1 is equal to 1 over sine theta. Now we've got the whole equation in terms of one trig function, sine theta, but we've got that nasty little denominator there that makes it a little bit harder to solve. So what do? We think, is there something we can multiply both sides by in order to get rid of the denominator? And of course there is. Let's multiply both sides of this equation by sine theta. On the right-hand side, we're going to get rid of that sine theta in the denominator because anything over itself is 1. So sine theta over sine theta is 1. And we have to distribute the sine theta on the left-hand side, and we get 2 sine squared theta minus 1 times sine theta is just sine theta. Now it's looking a whole lot better. It's almost in perfect form for us to think about this quadratic equation in terms of factoring, but let's move that 1 over to the left-hand side. So we have 2 sine squared theta minus sine theta minus 1 equals 0. Now we're perfectly positioned to make use of factoring and the zero product property. We set up our double bubbles to factor this left-hand side. We still have a 0 on the right-hand side. We need 2 things that multiply to 2 sine squared theta. So in one factor, we'll put a 2 sine theta, and in the other factor, sine theta. And we need 2 things that multiply to negative 1. So that's going to be a positive 1 and a negative 1. So both of these factors take a 1. And we need to figure out where to put the negative. When we multiply this back out in our heads, remember when we add the outers and the inners, right? We multiply the outers, we multiply the inners, and we combine those like terms. We need to be left with a negative sine theta. So we put the negative here in the second factor and a positive in the first factor. Now, using the zero product property, if the product of 2 factors is equal to 0, either the first one is equal to 0, 2 sine theta plus 1 equals 0, or the second one is equal to 0, sine theta minus 1 is equal to 0. So we're going to solve each of those equations for sine theta. Sine theta is equal to negative 1/2. Or sine theta is equal to 1. All right, I went kind of quickly through solving for sine theta, so pause the video if you need to think about that for a minute. And now we need to think about all the angles from 0 to 360 degrees, where the sine of the angle is either negative 1/2 or the sine of the angle is 1. So we need to look at all 4 quadrants. And think for a second. Sine of theta equal to 1/2. That's one of our special angles. Comes from our special triangle. The sine of 30 degrees is 1/2. But we don't want 30 degrees because we need the sine of theta to be equal to negative 1/2. So we're going to look for an angle in the 3rd quadrant and an angle in the 4th quadrant where the reference angle is 30 degrees. So theta is equal to, we're looking in the 3rd quadrant, we have 180 plus 30, so that's 210 degrees. Or in the 4th quadrant, it's almost 360, but not quite, so that's 330 degrees. And then the 3rd option comes from sine theta is equal to 1. That's not from any special triangle, that's one of our quadrantal angles. You can find that on your unit circle, or you could think about the graph of sine theta, and you might remember that the sine of 90 degrees is 1. And so we have found 3 solutions to the initial equation that we were given, and we're done.